Hi, I'm Angela Rasmussen from the University of Utah Department of Electrical and Computer Engineering, and today I'm going to do an explanation of the zero integral. So this is from class when I was solving this problem for IC of t, and we were doing the Fourier analysis, and we were left with this equation. So from this equation, it had two parts, and the first part we needed to actually do the inverse Fourier in order to solve it, and then the second part of this component here we could use just right from the table itself, because there was a result in that form which gave us this 5 times 10 to the minus 3 e to the minus 3 u of t. So when we integrate this term, we treat j as a fixed number, so we can bring it out in the front. So we bring j and 5 times 10 to the minus 3 pi. We treat that as kind of a constant number out front. And so this leaves us with omega delta omega e j omega t all over 3 plus j omega. From here, we can use a property that we know that delta is 0 everywhere except right at 0 is where it's going to spike. So whenever we have any function multiplied by the delta function, we can evaluate that because everywhere is going to be 0 except for at t equals 0 for this case. So that means that it is just going to be x evaluated at t equals 0 and delta t. So when we use that property, we can plug in 0 for omega. So all of this can be now our x of t, or x of omega in this case, x of omega delta omega. And we can just evaluate this portion of it at 0. So when we do that, this becomes 0 times e to the 0 over 3 plus 0. And so because this is 0 there, then we have that this whole term goes to 0. So when we integrate it, that term will integrate to 0. So that was why it was 0. Thanks for watching.